All right, today we're going to perform an activity that's based on Snell's law, the concept that you learned yesterday. In the end, we're going to try to find two indices of refraction of unknown materials here, material A, material B. To do that, we're going to perform two simulated experiments online on a Java applet. To get to that Java applet, to perform this experiment, and then I'll explain how to do the analysis, I want you to go to my website. On the left-hand side of the page on my website, you're going to see a little button that says applet test. Right over here on the left-hand side, applet test. Okay, then you're going to click on embedded applets. And then you're going to scroll down to where it says Snell's law there. Now, ironically, where it says click to run doesn't actually work to click to run. You've got to click just above or just below where it says click. So click right here, and it should take you to this applet. It may ask you if you want to update something. Don't update anything. Just go directly to that applet, okay? Once you're there, just wait patiently for everybody else to make it there. So click on applet test on the left side of the page. Click on embedded applets. Go down to Snell's law. Click on that. Make sure you get to the page that looks like this. And then just stop and wait patiently for a few seconds until everybody's in the same place. To find the index of refraction of a particular material, a material that we're going to call mystery material A, we first of all want to make our second material here mystery A. Okay, we had it by default as, I think it was water there when it started out. We don't want it as water because they tell us what the index of refraction of water is. We want to measure the index of refraction, not know what it is already. So go to mystery A, and you're going to get a screen that looks something like this. We're going to fire a laser beam through this, and we're going to see exactly what the angle of incidence and the angle of refraction are. We're going to use those two pieces of data over several trials in order to get the index of refraction of this mystery A material. Let's press the red button. You guys don't need to do the entire experiment here right now. Just kind of follow along with me for a second. Press the red button. What you're going to see is this incident ray coming down like this. It strikes the boundary. You get a little bit of reflection. You're always going to get that, right? You guys learned earlier on in your science studies that when a ray of light strikes a boundary, you're always going to get some reflection and you're going to get some transmission. We talked about that in Physics 20. Sometimes you're going to get more reflection than transmission. Sometimes you're going to get more transmission than reflection. Here it doesn't really matter what the proportions are. We want to focus on the part that's transmitted or refracted. So we want to focus on this ray and we want to focus on this ray. This will be our angle of incidence, we're going to call theta 1. This will be our angle of refraction that we're going to call theta 2. Now, how are we going to measure those angles? We're going to drag and drop a protractor over there. Bring this protractor over, set it up so that 0 is on the vertical line and that 90 degrees is on the boundary. So it should look something like that. That enables us to find the value of theta 1 and theta 2. Theta 1 would be measured from 0 all the way over here. Theta 1 appears to be about 45 degrees. Theta 2 is this angle right here. It goes from 0 over to, looks like 17 degrees. We're going to create a data table that has the angle of incidence in one column and the angle of refraction in the other column. In other words, theta 1 and theta 2. My first theta 1 was 45 degrees. My first theta 2 was 17 degrees. Okay, yours is going to be different, obviously. Now we're going to change this a little bit, manipulate the angle of incidence. All we have to do is physically drag this a little bit. Let's put it at, there we go, 65 degrees. If I put my angle of incidence at 65 degrees, right here, what's my angle of refraction? Looks to be 22 degrees. So I go back to my data table, I record 65 degrees and 22 degrees. You keep repeating that. You want to do that 10 times for mystery material A. Once you've got 10 data points for the angle of incidence and the angle of refraction for mystery material A, you're going to do something with this data. That's going to help us to find the index of refraction. What are we going to do with it? We're going to find the sign of each of those angles. So we had the index of the angle of refraction, theta 2, the angle of incidence, theta 1. take sine theta 1 and sine theta 2 and create a new table. Literally, punch it into your calculator. Whatever number you get should be a decimal number. Plug it into this table here. Once you've got your analysis table, sine theta 1 and sine theta 2, I want you to plot a graph. When we see this table, we should know automatically which variable goes on which axis. The first column is the manipulated variable, and it always goes on the x-axis. The second column is your responding variable, and it always goes on the y-axis. So this graph that we're going to plot is going to be sine theta 1 on the x-axis and sine theta 2 on the y-axis. When you do that, you should get a bunch of data points that give you pretty close to a straight line. Draw a line of best fit. Find the slope of that line, because you're going to need the slope to get the index of refraction. What are we going to use the slope for, or how are we going to use the slope to get the index of refraction? This goes back to the analysis you did in your last activity. That was our current balance activity, and an activity a while ago with momentum. Every straight line graph is represented by the equation y equals mx plus b. Every single one. If you get a straight line graph and you need to figure out what the slope represents, then write down that equation. Then what you want to do is take y and replace it with sine theta 2, because sine theta 2 appears on the y-axis here. Replace m with the word slope. Replace x with sine theta 1, because it appears on the x-axis. There is going to be no y-intercept here, so you can cross that off. Now we also want to get an equation from our data sheet. This one comes from the graph. We want to get one from our data sheet that has the same variables in it, sine theta 2 and sine theta 1. The one that we get from our data sheet is the one that we learned yesterday. Snell's law, sine theta 1 over sine theta 2 equals v1 over v2 equals lambda 1 over lambda 2 equals n2 over n1. Because we want to find the index of refraction, we're going to use these two parts. Sine theta 1, sine theta 2 equals n2 over n1. Now, just like we did with that last activity, the current balance activity, we want to rearrange this to take the same form as the equation that came from the graph. So let's solve for sine theta 2 here. Sine theta 2 is equal to n1 over n2 times sine theta 1. Sine theta 2 goes up by multiplying, n2 goes down by dividing, and 1 goes up by multiplying, and this is what I end up with. Cross off the variables that appear in both. Sine theta 2 appears in both. Sine theta 1 appears in both. Slope is equal to n1 over n2. Now, the slope you can find the old-fashioned way by using delta y over delta x, or you can use Microsoft Excel, and I'll remind you as to how to do that in just a moment here. Bottom line is you've got the value of slope. n1, if we go back to that applet, we have the value of n1. They tell us what it is. It's 1.00. So if we've got the value of n1, and we've got the value of the slope, then we can find the value of n2, which is mystery material A. Basically, it's going to be n1 over the slope. Does that make sense? Now, you're going to do this twice. You're going to do it with mystery material A, and you're going to do it with mystery material B. And obviously, you're going to get two different values of index of refraction, depending upon how much it makes light bend. Feel free to change material, the material that it's coming from, the incident material. By default, it's air, but feel free to change it to glass. Feel free to change it to water, or feel free to change it to a custom value where you can just put the index of refraction whatever value you want. Doesn't really matter. Okay, you want to leave it as air, go ahead. You want to change it to another value, go ahead. You're still going to get the same index of refraction for mystery material A and mystery material B as if you leave it for air. Now, once we have that data table, once we have that analysis table, If we want, we can plot the graph the old-fashioned way and do the analysis here, get the value of the slope the old-fashioned way, get N2. Or we can take that data and we can put it in an Excel table here. You can see the first column that I've got listed here is the angle of incidence in degrees, and the second column is angle of refraction in degrees. That's my data table, those first two columns. Your analysis table is column C and column D. We want to enter a formula into column C to calculate the sine of the angle. I've done it already for the first one. Notice what I've done there. I want column A, row 2, that 45-degree angle, and I want to calculate the sine of that 45-degree angle. So I entered equals, you can see up here, equals sine of A2. But notice what I've done there as well. I've written in the word radians. If you say equals sine A2, it's not going to give us the right answer because it thinks that cell A2 is in radians. What this does is effectively converts cell A2 to radians and then gets the sine of that angle. Yes, Excel is always going to be in radians, always going to be in radians. So what we're doing here is effectively converting cell A2 into radians and then calculating the sine of it, giving us the answer that we want here, 0.707. Now, the beauty of Excel, and we showed you this the last time when we did the current balance activity, we don't have to enter that formula 19 more times. We can copy it over to column D, and notice what happens when I copy it over to column D. It no longer says sine radians A2, it says sine radians B2. It automatically adjusts to the next column. Now I could fill in the rest of them by highlighting both of those, dragging it down. It's got everything I need there now. It's got all of them. Now I'm going to tidy this up a bit. I don't want all these decimal places in here. Let's get down to a couple decimal places. Okay, that's neater. Let's center all this to make it a little bit neater. Let's get rid of these red circles here. Got it centered. Let's bold this to make it neater still. Let's put some borders around this as well to tidy it up. Okay, that's a good-looking analysis table that we have there now. Let's go to plot our graph now. Here's how we plot our graph. Remember to highlight your Y column. Don't highlight the heading, sine theta 2, just highlight the numbers in there. Then you're going to go insert, a scatter plot. You get a bunch of seemingly random data points. That's not what we want. So remember, as we did last time, we're going to click on one of those data points, right-click. We're going to select our data. We're going to edit. You can see the Y values are already in there. We want to select our X values, which is column C. Click on that button, click on OK, click on OK again, and there's the graph that we want. Now we also want to label our axes and we want to put a title in. So let's click on this first chart layout. That gives us an opportunity to enter the chart title and to label our axes. Let's click on a data point, let's right click, let's add a trend line. It should be a linear already. Click on display equation on chart. And you can see that my equation for this particular graph is 0.4163x minus 0.0018. 0.0018 is the y-intercept, and it's so small that it's not going to matter. The important number for you is that 0.4163. Okay, that's your slope. I'm also going to get rid of this because I just don't like to look at that. Now, time for a write-up. Now let's highlight this as our data table. Copy it, put it into Microsoft Word under data, and it should look something like this. Let's highlight the entire thing for our analysis table. Column A, B, C, and D. Let's go back to Microsoft Word, let's paste it, and our analysis table should look like this. Now it's time to insert the graph. We're going to right-click this. We're going to copy. We're going to go into Word, and we're going to paste. Now you can adjust the size of this. In fact, you should. We want this graph as big as possible. So let's make it the width of the page here. Might go on to the next page. That's not a big deal. Make sense? What do you do after this? Well, effectively by hand, you're going to go through that analysis we went through just a minute ago to figure out what the value of the index of refraction is. And then you're going to repeat everything. You're going to do it for mystery material B. Does that make sense? Go to the applet, select mystery material A, get 10 different angles of incidence and 10 different angles of refraction. Get your data recorded. If you want to do it by hand at that point, that's okay. If you want to do it on Excel, that's okay and quicker. Trust me, it's quicker. Plot the graph. Go through the procedure that we talked about to plot the graph. Once you have the graph and you've got the slope, then make sure you can figure out what the slope represents. Once you've got that, you should be able to find fairly easily what the index of refraction is. Repeat it again so that you've got 2 indices of refraction and you're done. All I'm asking you to hand in for this is your data, which comes directly from this applet, your analysis, which comes from probably Microsoft Excel, the calculation of sine theta 1, sine theta 2, and your graph along with the calculation of the index of refraction for both materials. Is there any questions on that? Monday. Are we good? All right, let's get at it.